Okay, now we'll understand what is Venn diagrams. Okay, what is Venn diagrams? So Venn diagrams is developed by Venn and Ellior. So Venn Ellior diagrams are also called as Venn diagrams. So these generally consist of rectangles and closed curves, generally circles. Okay, like rectangles, closed rectangles. Rectangle is a closed figure. Rectangle and like circles or ellipse form like this, closed figures. Okay, with this help we can easily and very systematically and diagrammatically can represent the sets and sets and their relations between the sets, their common between the commonness between the sets, union of sets. Okay, operations on sets can be done very easily and we can understand very easily. Okay, now let us see. Okay, here let us see, suppose here you see is a given some example. As we see that the universal set is mu. Okay, in this there will be so many subsets and sets will be there. Okay, so generally a universal will be shown as like a very in the big rectangle like this, and remaining figures will be inside like this, right, like this. Okay, now suppose here the example in mu, see this is a subset of this mu. So mu is a universal set, this mu is universal, in this a is subset. A contains 2, 4, 6, 10 and 8 and the remaining are 1, 2, 3, like therefore totally 1, 2, 3, 4, 5, 6, 7 are. So odd numbers and even numbers is separated like this. So therefore totally this is like this. So it is, this even number is subset of this total mu set. What is the mu set? Contains 1 to 10. And the second one is mu is some numbers and a is subset, b is there. This is b and this is a. B is subset of a and a is again subset of mu. And this is a common. A and b are intersecting and this is the intersecting part, right? Like they are intersecting. This is the intersecting part and the elements intersecting is CD and here ED and here it is ED. So that means we can very easily understand and we can solve the problems very easily. Okay, so these are called the Venn diagrams. Let us see how these Venn diagrams will be there. Suppose this is universal set, general denoted by mu or some S or some U, and this is set S, set A, set B. This is a Venn diagram. Okay, so this has 4 parts. This is one part, this is another part. Okay, so this is another part and this is another part. Okay, like all these things. Now we can see that the elements or the objects, when we define a well-defined collection of objects as a set, suppose mu is a set, all these will have well-defined. So in the mu is a well-defined, A is well-defined, B is well-defined, and this part is well-defined, this part also well-defined. Okay, we can say like that, right? Suppose with some example, if you can understand, I'll show you with some example. Suppose all these are the, we can say this A is a set of, say, cricket players, right? These are the football players. Now here automatically those we can play cricket and football, and in the remaining place these people are here, they don't play cricket and football or both, but they can play some other game, or may not play, they may not play any game. Okay, so they are not in this. So like this we can say this. And here suppose if you consider this is only cricket players, here it is only football players, here it is both the players, here it is none, they don't play both the games, they may play other games or like this. Similarly, this is 3 sets we have taken like this, A, B and C. Suppose this is a math students, this is science, this is say economics. Now see how many reals formed is 1, 2, 3, 4, 5, 6, 7, and if I call this is like this, this is a mu is a universal set, then there will be how many, 1 2 3 4, how many regions are there in this? We'll mark this one: region 1, region 2, region 3, region 4, region 5, region 6, region 7, and region 8. 8 regions will be there in this. Now this, if I call this is a mass, so this set contains mass. Okay, these are all people will study mass. This people will only mass will study this part, only mass. And here this is both mass and science. If I call this is science, this is say economics. So only this region studies only economics. Here both economics and mass. Here economics and science. Here only science. Here it is economics and science and mass. This is the region, very important. This region is very important. That is all the 3 subjects they will study. And any person here in this region, they does not study any of these 3 subjects. They may study other than these 3 subjects, or maybe no subjects. Okay, so like this we can say all these are the Venn diagrams we can explain. And another is, for example, I have taken this is a universal set, and we have taken, there are one set is there and there is another set is there. Okay, there is like this is there. Okay, so therefore this is subset of this one, this is the common area. Okay, this is subset of this one but not this one. I can write here one more. Okay, so if I say this one, this is subset of this one but not this one, not in this. Okay, so like this we can say, we can call another. So like this, all these are the Venn diagrams. They will show us how they are mapped or how they are related. Okay, now for example, this is mu, this is one set. Okay, so this is A. If I call this set, this is called as A dash. Means all this is A, some elements must belongs to A or A dash, means total A union A dash, this total will be equal to mu. This area and the remaining area. Remaining area, what we have seen, this. Is total this area and this area, total including what? Mu. Right? Similarly, if I take a universal set, and this is one set and this is one set. Okay, so there are 2 subsets we are in this. Okay, they are different 2 subsets, they are not intersecting, but they are the subsets of this one. Like there will be many subsets will be in this universal set. Okay, we'll stop here.